Hi. So I think that it's time to start right now. Let me present myself. So my name is Alberto, and I work here in CARTO. I'm the CTO since 6 months ago, more or less. And I would like to talk today about how a project and a product that we are creating in CARTO that lets us to offer different geospatial data sets, and that the product is called Data Observatory. In this case, today, I would like to talk to you what is Data Observatory, what we are building here, and I would like to talk about one big data set that we are including there in the Data Observatory. It's a data set that comes from MasterCard, and it is a very big use case, and I am going to explain how do we solve it to serve this huge data set, and how do we use that to build up our product. And so our main idea is to let's start with a very difficult data set, and after that we are going to generalize to another kind of data set that are more easier. And the MasterCard Dataset is the biggest one, and here is basically what we have is a data set that's one single table takes 2 terabytes of data, and it took around 20 billion rows. Let's start. Let's talk about what is Data Observatory. And Data Observatory is a product that CARTO is offering right now. If you know and you have heard about CARTO in the past, CARTO was focusing in data, and we create a product that was called Builder, and also an engine to power all the geospatial intelligence behind Builder. And there, the idea of CARTO was more focused on visualization and also in some kind of analysis. But right now we are trying to move forward to address other kind of use cases. The visualization is there, so it's like another expansion for CARTO business. And that's one is related with, for Data Observatory, we are mainly focused on to create a repository of curated data sets. Data Observatory was created in CARTO before, that was version 1, but it has some trouble instead of data management, because we need to have to support operation for bigger data sets and to improve the integration outside of Builder and outside of CARTO platform. And there is what we create. We create a repository of curated data set, of geospatial curated data sets, and the main goal was to reduce the time a data science spent on gathering and cleaning the data. CARTO created a partnership with Google 1 month ago, more or less, to offer public data sets from CARTO in the BigQuery catalog there. What is the idea here? The idea is that, for example, if you consider that you receive one day one layer with, or one data set with zip codes, and the data set is like you have the revenue of your customer, and it is organized by zip code. And you, for example, want to create a model, and you want to have more information outside of the data that your customer has provided to you. Like, for example, you want to have demographics data, or you want to have transaction data from MasterCard or from BBVA or wherever. So this time is quite hard, because the first thing that you need is to have a zip code layers, and in order to enrich with other kind of data sets. And it is something very, very, let's say that is not direct. And you will need to deal, if you want to represent the layer over a map, you need to talk with Correos to get a layer of zip code. You need to talk with a lot of different people to get the data. You need to get to the data provider to listen to the data, and we want to speed all of the process. Right now, the process is 80% for gathering and cleaning the data, and 20% to process and to invest time in the data. And that is what CARTO wants to reduce. We want to reduce this time, and in trying to flip the numbers, to say, okay, let's go into spend only 20% of the time gathering and cleaning the data, and the 80% doing more useful thing with the data. And for that, CARTO has a product that is CARTO Friend, and we have there a version that integrates with the Data Observatory, and that provides data augmentation, analysis, model projection, and stuff like that. And it is like a new CARTO UI for Python notebooks. and it's more for addresses data scientists. And the other thing is the data observatory for developers, and that is what we are going to talk today. It's about a low latency API for developers that lets you to create a map using our API without the need of downloading the data or doing a lot of other stuff. And that is what we create is an API for developers. That is, you mainly have a measurement endpoint that gives you the data. And for that, you don't need to be a geospatial expert to get the data. Let's give an example. Consider that you have a data set with stores and you have the coordinates in a lat long. And what you want to know is how many people live in the area, or you want to know what is the number of transactions from BBVA or from MasterCard or wherever. And you can do a request to our API and we get to get the data back to you. So you don't need to know about map and stuff like that. And the other is something that is more related with map. And we have created a visualization endpoint that is that produce a child vector endpoint in map vector tile that is like the standard right now for maps. We have another data format that is coming, and we are going to improve that. But right now, that is the very basic, and that is what we are creating for create the application for MasterCard. So let's start how we start building this application. And right now, because for understanding this it's a little bit hard, but it's important to understand what I am going to tell you after that. What is a system of tiles? I don't know if some of you have worked with map before, but basically the idea how Google Maps and other systems works in the past is like you have a very big division of the world. You start with the world in zone 0, and after that you divide the world in 4. And every single tile consistent on divide the world in is different time. Let's see an example because it's more easy to see here. I don't know where is the mouse. Okay. So as you see here, it's like a way to produce the maps. In the past, when Google Maps created that, what Google did is to create a bunch of different images. And the Visual Web, what it does is, if you provide the zooms 1 and you provide the X and Y, the server gives you this image. After that, for this is 0, sorry, it starts with X0 and X1, and the EY start like that, okay? And once we continue and improving that in the future, we just change the format. We just change the format for providing a vector format, and the client side using WebGL and other technology was the ones that render in the map, okay? But the idea is that we pre-calculate, and Google did that, and also is the system that CARTO uses, like to pre-generate this kind of images around the world. So if you do zooming, if you start doing zooming here, for example, you will see that the number increase. So in this case, we are going, if I do another extra zoom, the tile is going to divide in the next zoom level, that is 5, and we are going to have different X and Y. And it is our way how we divide the world. So basically the idea, when you are generating a map, you need to generate the data for this tile. Some cases the data is just an image, and in other cases the data is in a vector format, it's in a binary format. Okay. Let's continue. So here we started with MasterCard Datasets. And we started the project when MasterCard provided these datasets. We were pretty scared because what they say to us is that, okay, I'm going to provide you a huge dataset with daily data, and you need to create map using a time filter. And that is huge because MasterCard provides the data. It's like in a very small grid. Here in block groups is a territorial unit that is pretty small in the United States. It's like 200 meters per 200 meters. And there you will have for each territorial unit, you will have a data set of transactions. And there you will have the time, that is a constraint, and you have 3 different fields for 3 different kind of categories. So the amount of data that you have per a single boundary, that is for every single region of the space, is 5 times, that is the number of categories, times 3 segments, try 3 geotypes, times 5 years of data. That 5 years of data is 365 times 5 years. And there, the amount of boundary that we have is 11 million. So the total amount of the data set is 2,710 billion rows. But the good is something that is quite hard. Unfortunately, it wasn't true. Our suspect is that in every single block group in the United States, you don't have always transaction for every category. That means that you don't have an store every 200 meters. So this amount of data was reduced to these final numbers. So in this case, you have 11 billion rows. You have 11 billion rows for that, and that was the real truth. But as this is a huge data set that we need to deal, and we need to figure it out how we are going to manage this data set to serve in our low latency environment. Because our goal, our main goal when we created this product is say every single tile that we remember before, when we create it, needs to be rendered in less than 1 second. And that is the final product that we built in the front end. And the idea was, okay, we need to create a product that with these 2 endpoints, we need to be able to create all of this application. And if you consider this map and you divide this in tiles, we need to do requests for every single tile. And here in the combo, if you remember the original data set, you have here 1 category, you have here another category, and you have here another time selector. So the request that we need to do here is to, 1, is to ask for the math for the information for every single tile that you have in the map, and also for creating this time series. And the idea, and also MasterCard created to make the things more difficult, is something that I'm not going to explain here because it's too much. How do they create some kind of benchmarking rules to guarantee that the data is not delivered with the proper anonymization? Like, for example, they need to avoid, the legal department for MasterCard needs to avoid that you can figure it out how many transactions happen in a commerce or wherever. Because if you consider that here you have only a shop that, for example, is in 1 single block you have El Corte Inglés, they won't want to deliver this information. And that is how the application is work, and that is running using this backend. Also, for this case, it's also pretty interesting because we are doing the same, but in this case, we are asking also for different time selectors. That this lets the user to compare the data in July 2019 and July 2018. So it's double the size of the amount of the data that we need to do. So the first things that we did is, for creating this kind of time series data sets, we create some kind of rules to reduce the amount of data that the user needs to ask. So for example, what we say is, if we have data per days, we are not going to let the user ask for more than 60 days. Because if you want to ask for more than 60 days, we are going to jump to a weekly aggregator. So the idea is that if the user asks for 6 months of data, we are not going to go to the daily data. We are going to create an aggregate of the data per week, and we are going to offer data. And if the user selects 5 years of data, we cannot go and check per every single tile the 2 terabytes of data, because it is not going to work. So the idea is that for if you select 5 years of data, we will go to the aggregator per month. And in that case, always we keep that the idea that we are not going to ask more than 60 days per each query. And here, if you remember what is a tile, and in this case, I'd say let's focus, for example, that you want to render this part of the map. This small corner over here is just a tile that we need to ask for the data. A tile request that can ask for 2 months, because we talked about the comparative mode, we are going to ask for 60 days. And the average of a tile is pretty much 300 of geometries. I did the number in my head, so that is probably wrong. But it's something that makes sense for me. But we work with the worst case scenario. We take the biggest one, that is some tiles in Manhattan, that is like 1,000 of boundaries inside of a tile. So for that, we need to fit like 60 days, and we have like 1,000 boundaries. So that means that in one request, we need to go to the database with the limitation that we have created here and ask for 60,000 features in no more than 400 milliseconds. And that is the expectation when we started creating that. And the decision is like, we need to pick up a database. So at the beginning, our idea was, okay, we have different options. We have ClipHouse, we have PostgreSQL, we have the Spanner, we have BigTable, we have Aurora, Resif. I think that with this kind of limitation, if you work with any of these solutions, you will find some result. One of them will be easier, one of them will be more difficult, but some of them will be more time consuming. And here, the first one, why do we finally decide Google Cloud Spanner? Why? Mainly because CARTO have a contract with Google Cloud, and we need to spend the money on Google. So we don't want to have us to host the service for our own, and to have a cloud database, self-gestion and stuff like that was pretty easy. Using ClickHouse, why we discarded ClickHouse? Mainly because we don't have this in Google platform, and we don't have the expertise to manage all the things in the database. PostgreSQL, we have the expertise, but we know that manage this kind of thing when, for example, you need you receive a new data set and you need to create, you need to remove the index, you need to create the index again. So it's going to be quite hard to manage this in Postgres. And the other solution was Google Cloud Spanner and BigTable, because Amazon Aurora and Resif for us is like what with Amazon, we don't have a contract with her, and that is going to be an expensive product if we are going to include a lot of data sets. So we finally decide to go with Cloud Spanner. And a spoiler, we made a mistake. We failed, we totally failed there. Because why we selected the Spanner? Because we thought that we can have a database that ran the aggregator for us. Because the difficult thing with BigTable at the beginning was, okay, you need to move the data from the database to the client and to run the aggregators. And that is quite hard. Why also we decided Spanner? Because Google advised us to use it. Google tells us the story that they are using BigTable in the past, and they are migrating all the product that they are using BigTable to Cloud Spanner. And we believe that, and I think that they are working on that, and probably Spanner is a good product for other use cases, but not for us. I am going to explain why and what are the problems. And another idea is because it's very easy to scale with more data. If we have a new data source that is coming in the system, we say, okay, if the data set takes 1 terabyte of data, we do the calculations and say, okay, it's going to cost us $1,000, and we are going to add our markup and say, okay, here is the price. So it's pretty easy because you don't need to figure it out how you are going to ingest and stuff like that. It's a more standard way. But what not went pretty well, I think that it was not faster enough with joins, probably because I don't know if we didn't use that properly, or we didn't understand the product, or what's happening there. But after that, we created a model that was quite similar to BigTable. When we have problem with the aggregator, we say, okay, well, let's try to pre-calculate this, let's try to change the data format, let's change, and at the end, we say, okay, we are using something that is quite similar to BigTable. And the other thing that is quite slow, loading the data. And this was something that is tricky from the documentation of a spanner, because we have only 5 megabytes with 4 nodes. And what is the problem there? That is, the documentation of a spanner said that you can have 10 megabytes per node, 10 megabytes per second, and say, okay, 10 megabytes per second is reasonable. I will take like 3 days for loading the whole data sets, but for a big data set, it could make sense more or less. But the tricky part is that they say that you can take 10 megabytes per second, but you have several different limitations. One is that per each commit, you need to run 20K of transaction. And they say that every commit to get this speed needs to have 1 megabyte. And what's happened? If you have a data set of numbers, you are not going with 10K of transactions, you are not going to get 1 megabyte because it takes at the maximum 100 kilobytes, 200 kilobytes. And that is something that is quite hard. And the other is that the ingestion for a spanner requires a specific ETL that you partition the data. And after that, when you partition the data by primary key, you need to launch a bunch of different processes. So when you need to order a huge data set, it's not an easy task. And for that, you say, okay, I'm going to need an spanner for doing the ordination, and after that, ingesting a spanner, so it doesn't make any sense. And also the other conclusion for us, that it doesn't look like a good production-ready feeling. Why? For example, they don't tell us what is the size of a table. And it is impossible to check in a spanner what is the size of a table. There are a lot of tricks on the internet. If you do a quick research on Google, you will say that is something I say, okay, guys, I have is that is quite expensive and we don't know that. So we decided to move to Google BigTable. And it was a good approach for our use case. And it worked. We accomplished the time and we accomplished what we need to build. We were able to ingest using 10 megabytes per node, very easy. I think that we can improve the CTL to get more speed. But right now it was like a script that I write this script and it was like 8 hours of a script and we get this time. And I spent much more time with Spanner and it didn't work. And also that is easy to scale up and to scale down, and is cheaper than a Spanner. A Spanner is twice the price of BigTable, basically. What that means is that, again, a Spanner could be, I think that a Spanner is something more to compete with Amazon Aurora and stuff like that, but it's not for storing very huge data set. It's for having a relational database that is easy to use and that scales. So if you want to create and you have million of rows, 10 million of rows works pretty well, but when you have this amount, it didn't. And here, one of the hard things with BigTable was to guess a good key design, and for that, we organized the time series based on that. So the original idea is to work with the geotype, after that with the segment, the industry, and the GeoID. And after that, if you check that you have the data in one GeoID, you have all the data of 1 month inside of a row. So and if you remember our application, what we do is that if you have a time frame that takes 60 days, you only, that for example, because we are limited in 60 days, you only need to check 2 months or 3 months. Because if you check August, you check September, and you check July. And with that idea, you go for one GeoID, forget all the data, you need to go only to one single row. And after that, you apply some filters and you get the metric that you want. Because if you check our measurement, we are only offering 1 metric. So basically, we are checking the month here, but if you are interested in transactional account, you only need to take this column, this cells of data. With the approach that we have is 1,000 GeoIDs times 60 times 1 column, we get 0.4 seconds per child. And the main difficulty that we found with BigTable, that was not easy to find a good design for the key. We try at the beginning to get advantage of the range filter of BigTable, but it didn't work pretty well because we have different GeoIDs that doesn't correlate in all countries. In some cases, the GeoIDs are pretty close between them, but in this case, there is no relation that you can get a range there. Also, another thing that was quite hard was data flow. Data flow for us was a little bit of mess, and it was, for a spanner, was a complete disaster. We detect like 2 or 3 bugs to Google, and they try to fish with us, but it was very time consuming. And what's the main thing with BigTable? For me, it looks like the data flow have some kind of a script very well documented and supported by Google, but the rest are supported by the community of Apache Beam. They lack of documentation. Sometimes the things didn't work and stuff like that. Another thing is to avoid complex filter. One of the things that we thought at the beginning, okay, if we add some kind of filters to BigTable, we are going to get more speed. But it wasn't true. If you add some complexities using complex regular expression in the filters, it didn't work pretty well. And another thing that is pretty important is to warm up. They say on the documentation, but never you realize, I don't know, I don't know why, but Google says in the doc, say, okay, that is very important that you have. If you are using BigTable, you need to have a data set bigger than 300 gigabytes, and you also need to warm up the database. And one of the things that we detected is that suddenly the performance goes down. And what we did to perform that, because we were testing, the system was not yet in production, we did a warm-up for 1 hour, 2 hours, and we have a script to do the warm-up. It started working, but after that, after a few minutes, it goes down the performance. So the idea for that was we just created a string, and always, if we are not getting requests, we continue asking random things to BigTable. Random things in the story is what we do. So that's the idea, that you always need to keep this string up. Other thing that we discover, and it's something that right now is under development to improve the 0.4 seconds, is the more amount of columns, the slower. That is related with the benchmarking of MasterCard. We need to continue defining more and more to fit more columns to run the benchmarking to create this kind of thing. Benchmarking for MasterCard doesn't mean benchmarking in the sense that we understand. They call benchmarking to create the rules for create the anonymization of the data. That is the summary. A lot of fun with the workflow. I enjoy a lot even working with the spanner and trying to figure it out and trying to get the performance there. Always, I do it always with the monitoring console, checking all time, say, okay, that is getting 50 megabytes per second. Let's go. I need to speed it up a little bit. I need to go more. The other thing is that BigTable for us was like a product that works as expected. It did what the documentation says that it needs to do, and it's working. And also, it has a good rate, the projects for delivery and time spent. And the other thing is that it's not a hard maintenance on the infrastructure. It's just a matter of you want more node, you add, you want to reduce the node, you delete. The only hard thing that I complain from BigTable is that you cannot rename a table. So when you have a data there of 2 terabytes and you made a mistake with the name and you need to rename again, it's absolutely pain in the ass. Because you need to basically to reload it again. And also it's a good mapping with business for adding more complex data sets. If we need to add more complex data set, we just calculate how it's going to cost in BigTable, and we can add our markup, and that is scaled very well. It's work better for the 2 terabyte table, and we have another different tables in the system, and we start creating them even for a small table, for big table, and stuff like that. Something that is confusing sometimes in the application is in the documentation is that BigTable say that you need to have 300 gigabytes per table to let BigTable work properly. But it's not related with a table itself. It's related with the whole side of BigTable. But it's good. And that's all more or less. I don't have more things. The next thing is that we are looking for a lead for data engineers. So let me do the spoiler here. And if you want to join the team, it's totally welcome, because we are trying to find a lead for the data engineer. We are just creating this team. It belonged before to the CARTO backend team, but we are doing more and more things related with data, and we are creating this team, and we are looking for someone to lead these two very big projects, that is all the projects related with Data Observatory. And that's all. I would like, thank you very much. And I would like to pass the microphone if someone has some kind of question or whatever. Don't be shy.
Thank you. I wanted to ask if you are adding more and more data every month, and if BigTable is still behaving well, or is it not expected to keep growing?
Yeah, we are ordering more and more data every month. So in fact, MasterCard are sending us data every month, and we need to add the data every single month. I have showed the case for United States, but for example, this month we have had another 3 countries that is the same data set for UK, for Canada, and for Australia.
And you just add more nodes? And
yeah. Basically, the idea with BigTable is that you need to have 1 node per each 2.5 terabyte of data. And every time that you need more data, you add more nodes.
And how are the geospatial operations in BigTable?
There is no geospatial operation in BigTable at all. So for that, what we have is, we are limited in this with the boundaries of the countries. So the idea is that we are offering different data sets, but the data set needs to match with the boundaries of a country. For example, if you want to consume this API, you need to have the metrics in the standard boundaries. So in the case of United States, it needs to be in block growth, census tract, and stuff like that. And in Spain, it will be municipalities, province, in the standard. We have another format that is a grid, but I didn't have the time to explain what is a grid, if someone is interested in that, because in fact, the truth is that MasterCard provides the data in 1 grid, and we need to compose from the grid, we create the aggregator. But it was quite hard to explain in a quick talk. It's more like, it's a complex ETL, and I don't want to, it's too many things for.
Thank you. Any other questions?
Thank you. 2 questions. Are you using different column families, or just a big column family for all the columns?
1 big column family.
Okay.
Because I have also, one other thing that we are doing is right now, because it didn't work pretty well with when we are more columns. One thing that we are doing right now with the benchmarking is to move 1 metric to the row key, and to have only 7 columns per family. We try to create different families, but the performance was pretty much the same.
Yeah, okay, thank you. The second one is, how did you pack and unpack the data from because for numbers it works well, I think, but when you have categories or floats or things that are not integers, you have to pack and unpack the data on binary format, or that's already fixed? Yeah,
but it's already fixed. Basically, we are using BigTable with Python, and we are using a library that is the standard is the struct in Python. And what we do is you can encode the bytes even like 1 array. You say the first element is an integer, the second is and we are using a write in the new performance approach.
Yeah, that's what I meant, that you have to take care of that at the application level.
Yeah, okay. Yeah. At the end of the day, BigTable would understand it from bytes.
Thank you.
Hi, thanks a lot for the talk. Did you benchmark also BigQuery, or you didn't have to because BigTable worked fine?
Yeah, BigQuery, in fact, we are using BigQuery for the other platform, that is Data Observatory, but BigQuery have 1 positive thing and 1 bad thing. I think that the good point for me from BigQuery is that it's very cheap instead of of data storage. The data storage is almost anything. And you only pay by computation. And why is that? It's because Google have the data in storage. So anytime that you run an operation against BigQuery, Google needs to take the data from the storage for GCS. It's like the bucket of Google Cloud. And they need to move that to the instance of BigQuery and to run the process in parallel. And this has a very huge problem for this kind, is that the latency. BigQuery has a huge latency. They are trying to remove creating a cache that they put in front of BigQuery, but it didn't work. The problem is the latency. If you include here BigQuery, every single time is going to include you more than 1 second of latency.
Hi. I just want to ask you if with this approach, did you solve the problem that you had with the aggregations, or you're still having some kind of issues with the aggregations that you mentioned? That
Sorry, I didn't understand the question.
You mentioned that you have problem with the aggregations using Cloud Spanner, that when you aggregate by more than 60 days, you were having some problems.
No, it wasn't a problem with the aggregator itself. It was more a problem with the performance. We try to use Spanner because it's have a way of creating the aggregators. And if we have a data set that run these aggregators there, it will be easier. And if you have a data set in Google Cloud or something like that for that, could be done very well. I think that, for example, I think that other databases like ClickHouse, for example, I thought that Javier and Raul have more experience in that, but I think that probably BigTable, ClickHouse is able to do that.
Thanks.
But the problem is that you need to manage that and you need to train the team to understand that. Yeah.
Any other questions? Well, thank you for coming today.